Okay, in part 2 of this little video series, we're going to evaluate the integral we got in part 1. How are we going to evaluate this? Well, like any good algebraic expression, we're going to start from the inside and work our way out. So what I'm going to do, I'm going to look at this little integral right in here. And while not worrying about the outside, we're going to try to evaluate the inside. And what am I supposed to do? I look at this thing in here, right? The dy tells me that the x is a constant. So what I want to do is take the antiderivative of this with respect to y, thinking that x is a constant. So that's what I'm going to do. I'm going to write down 25y, because that's the antiderivative of 25, minus x squared y, because that's the antiderivative of x squared with respect to y, and then minus 1/3 y cubed. And I'm supposed to go from y equals minus 4 to 4 like that. And minus 3 to 3 is still there. Let's see what sort of things we get here. 25y should be 100. 25 times 4 is 100. I'm plugging in 4 for y. Minus 4x squared, like that. Minus 64 thirds, like that. And then I put a big fat minus sign. And now I have to subtract everything I put on the bottom. We're just using the fundamental theorem of calculus. I plug in a minus 4, I get minus 100, like that. I plug in minus 4 into here, I'm going to get plus 4x squared, like that. When I put in minus 4 in here, I'm going to get plus 64 thirds, like that. And this is all the x. So I'm going to get here. I'm just going to start trying to combine like terms before I try to do more anti-differentiating. So minus 3 to 3. I'm going to get 200 minus 8x squared minus 128 thirds. Let's see here. This is dx. I'm still doing some simplifying. I really shouldn't have to, but here we go. 600 minus 128, that's 472 thirds. So I'm going to get 472 thirds right there, minus 8x squared, like that, dx. And I think that's right. And now I'm just going to take the antiderivative. This is now completely a Calc 1 looking integral. Antiderivative of 472 thirds is 472 thirds x. Antiderivative of minus 8x squared is minus 8 thirds x cubed. And I'm going from minus 3 to 3, like that. And so I'm going to get, I plug in that I get 472 minus 8 times 24. I think that's 192. I'll let you check my arithmetic. When I plug in minus 3, I'm going to get minus 472. And then when I plug in minus 3, I think I'm going to get plus 192, like that. And so what I should be getting, after all is said and done, I'll get, let's see here, 944 minus 384, which I think is 560. And again, I'll let you check the arithmetic. I'm not actually worried about the arithmetic at the moment. I'm worried that we started out with an integral. We just started from the inside. We worked our way out. The first time we took the antiderivative with respect to y, because that's what that first one said anything inside that integral that's not y is a constant. And so we were actually taking anti-partial antiderivatives. Yeah, that's it. And we plug in 4 minus 4 like the fundamental theorem of calculus tells us to do. We simplified a little bit. We just did this in integral like a Calc 1 integral, and we get an answer. So we set up the integral by chopping. We did the integral just starting from the inside and working our way out.